can start the next session. We're running a little behind the schedule. Sorry, we're running a little bit behind the schedule on the program. That's okay. I think what we'll try to do is end everything by about 6:30 anyway, so that we can have time to decompress before the banquet at 8. And I'll show you a map to where we're going.
You're going to show the map again?
Yeah, I'll do that. Yeah. And we do want to have a last few minutes to kind of wrap up today too. So we'll try. Let's see, it's now about 3:45. We'll try to do this in about an hour. Actually, what we're going to do now is it's kind of an extension of the last session. I think we'll have some similar issues to discuss. What we're Dušan and I are going to do a little bit different. We're not just going to talk. We're going to demonstrate, and the materials will also be available tomorrow to play with. There's a line of studies of work that developed, and I think most of you are quite familiar with it by now, following the study of public studies in methodology. Can't say the word still. That a little bit different. It's related to the studies of work program, and some of the same themes and demands come up, like especially unique adequacy. But it's exemplified in a number of studies. Probably the first that at least Garfinkel claimed exemplified it, the author might not have, was David Sudnow's Ways of the Hand, where in a sense develops his analysis as a kind of pedagogy, following his own pedagogy through playing improvisational jazz at the piano without other people present, but still giving keyboard sensibilities and a progression. Eric Livingston, who was a student of Harold's in the 1970s and 80s, is probably was very important for Harold's thinking along these lines when he did his study of the methodological foundations of mathematics, and then has continued with similar studies. Earlier today we mentioned, somebody mentioned his book on ethnographies of reason, in which there's a number of cases like playing checkers and origami, the artful folding of paper into figures. And Dušan has written about Galileo's pendulum, and we're going to do a little demonstration of this. And also Harold himself did a kind of a reproduction of another Galilean demonstration of rolling a ball down an inclined plane and measuring the acceleration. And it's Livingston himself, after giving you, to me, incomprehensible lesson through Gödel's proof, went to more simple examples from algebra and solving problems and proofs of things like the Pythagorean theorem, so it was a little more followable for those who didn't progress too far after a year or so in college mathematics. The Galilean experiments, what Garfinkel was doing with the inclined plane, what Dušan has done with the pendulum, what Eric Livingston also did a thing on pendulum. Dušan and I did a paper or two on Goethe's exercises, refutations of Newton with prisms, the optics. They're all designed specifically to be pedagogical as well as descriptive and demonstrative. And a reader of the texts in which they're described is treated to the possibility of actually redoing the thing at home. It also, I think, has an interesting relation to studies of education, in that Wendy was telling me earlier today about an experiment used for kids in education when schools have resources to do these things, where they do demonstrations with very simple kinds of materials for obvious reasons. One is the sophistication of the audience, the amount of time and trouble and money that it takes to do these things. And Sudnow and some of Garfinkel to Merleau-Ponty's sense of embodiment. And the idea is that at this simple level, you can engage with at least some of these themes. I like to liken it to Wittgenstein's remarks on the foundations of mathematics, where early on he says that he's mostly going to use elementary examples from arithmetic, counting, things of that sort, and use this to teach mathematics, because it's as good at mathematics as any, so why not start with these elementary things? I think there are a lot of questions that these sorts of practices raise, and I'm sure that this group has been very good at asking probing and challenging questions so far. So the idea then is that there's a pedagogy, but the pedagogy is designed to teach about practice, this practice in particular, but practices that these are kind of iconic for in the cases of experimental demonstration. There's curiosity, why Galileo? Actually, Dušan wanted me to try to round up somebody here in Manchester who'd get a hold of a, was it 3-meter long plank, a board, so we could do the inclined plane. I said, Dušan, how about something a little more transportable? And we're back to the embodiment of the demonstration in Galileo. Now, obviously, this is historically ridiculous, right? We are not reproducing, we're not replicating Galileo's experiment, although we can get it to work, whatever that means. And it's obviously different materials, different time, different context of investigation. And Galileo's text, where he describes this, is very limited, so it leaves tons to the imagination. So it's a device arguably related to natural philosophy, prehistory of science, that at least allows us to engage in not only dialogue, but a practice. Many of the practices that people in ethnomethodology study are described, but described for audiences who have no possibility within their lifetime or any short time of engaging in the practices themselves, like Bjelić's excellent book on scanning probe microscopy. You couldn't do it unless you spent all this arduous time or happened to have a background in physics or material science that would allow you to do this. So this kind of thing, although it's not superior to the description, does provide a different kind of engagement. So are you ready to launch into it? But are any preliminary questions before Dušan takes over and shows us the apparatus? Okay, well.
Okay, all right. Let me suggest that and give example of what might surprise you to be a radical phenomena, which is American flag. Probably you're not familiar. There is a code of American flag, how American flag has to be handled. It used to be statutory, which is if you don't follow the code, you can get penalized. But it was removed somewhere in the 70s. I think in Washington, D.C. still applies. But what is important about this code is that, for example, things that you cannot do, or that is against the code, you're not allowed to represent the flag. You're not allowed to make a picture of flag. You're not allowed to paint the flag. Why? Because if you take a picture of the flag, you won't see the other side. Flag has to be seen at once from both sides. Flag has to be in element. So in other words, you have to see a flag moving by the wind. Flag cannot be moved to a different planet, as Americans did to put to the moon. That was against the code. Flag had to have a certain size. You've seen, American politicians having a little flag, right? That's against the code. Or a little flag, that you put on a cake, or make a clothes with the flag, or when the Olympic Games they carry a huge flag. All of this against the code. So I had a group of students who formed students for the flag. So they took this code and went to the military and police departments and hassling them, saying, "You are not patriotic because you're violating the code." And so it was an example of insisting on the radical phenomena of the flag, in which flag, actually, you have to be with your body present to see the flag as it was meant to be seen. And even, the ending or the killing of the flag has to be with element. You have to burn it. You can't, just bury the flag or do whatever. No, it has to be burned by fire. So in that sense, what we have here is something that if you want to see, you have to be here. That is to say that here method travels, and you have to travel with the method, which we're like an ambulatory method. There's a 911 call, and then we come, or like a circus, we bring all our beasts. And here's where things happen. So what is happening here is a thing called pendulum, which is a very, very simple thing. And if you remember reading Kuhn, he argued that it is this instrument was the first scientific instrument of the new science that basically brought Catholic Church worldview to the ground, right? So you have something very, very simple that had dismantled something so complicated. There was a nice line in Brecht's Galileo where he was sitting in front of the cathedral and playing with a pebble, and when the Jesuits walk out, he will ask them, well, why doesn't this stone fall up? Why is it coming down? And so here is an example in which change of use of things can have such a radical implication for the rest order of the things. Because in Aristotelian physics, every object, physical object defines its own presence and its own location, its own speed, and so on and so forth. So whatever things are, they are in their own essence, so to say. So they're like rocks are in a place where rocks are supposed to be by its own nature. So all things in the universe are like books in a library. You have your place. So the movement in this context is perceived as epiphenomena, as a deviation of an order, and that's why Greeks and Aristotelians were not interested in a movement of the things, but rather in its resting place. And so, in a certain sense, if you look practical world, things that we use are also more or less situated on the basis of their ready-to-hand use. Like their instrumentality has its location, and our practices are structured around repeating those usages of these things depending on the purpose at hand. Now, it doesn't mean the thing is always what it's supposed to be by definition, like this is a table that can be used for eating, but can also be used for sitting or sleeping or whatever. But there are certain limitations to its use. And so when Galileo took a pebble from its natural place, started dropping it and asking a question, why is not staying in air but is dropping down? The question is, why was that so irritating to the Jesuits and the church? Why is that so unnatural? And what did this unnatural usage, how does this natural usage bring into question all their worldview? So Galileo, of course, devised many experiments, one of which, or instruments, one of which was pendulum. And the reason why he used pendulum, because he was concerned with the free fall. And it was very difficult to demonstrate physically free fall. You will have to have a long distance, plus seeing it, one demonstrate what he wanted to argue, and that is that contrary to Galilean, Aristotelian view that objects fall with the same speed depending on their weight, he wants to argue that regardless of their weight, they don't have a constant speed, but they have a constant acceleration. So to show that you cannot see, so then he devised inclined plane, where he will show the acceleration of the moving object. And part of this set of demonstrations, he used pendulum to show various consistencies between the movement of the pendulum and certain mathematical claims, because the whole point is to show that mechanical motion is happening according to mathematical law, right? That is to say, mathematics is applicable to the movement of the objects, which was inconceivable for Aristotelians and Jesuits because they regarded mathematics something equivalent to just music, just listening and seeing harmony, rather than seeing that as an application to physical world. Now, Galileo first studied medicine, but he was also very well-skilled musician. So his father was a musician too, so he had a very nice ear. And one of the things that he did as a student is to measure pulse. So he discovered that pulse produces irregular time units, right? And that these different people of different weights and age produce regular beats, but within a different with a different rhythm, right? So he figured out that there is a relationship between the size of the body and the beating of the heart. Nonetheless, he also sensed that that there is a certain synchrony of all those various beats. There has to be a time in which all heartbeats in their different rhythms must hit at the same time. It's like emotional movements, right? They move, but there's a point in which they all align and they go away and so on and so forth. So there was this musical thinking that Galileo talks about in his science that gave him a sense of mathematics as something that can be used as a formal musical element that can be used for explaining the movement of objects. And so in that sense, pendulum is like a beating heart. In fact, one way that he measured the movement on the inclined plane is at the time when there was no mechanical time, was that he will take he will take like a healthy man and try to get length of the pendulum consistent with the beating of a heart, because assumption is that the healthy man or healthy woman's heart beats unit, which we today call a second, right? So that's why your heartbeat is good when it's 60 beat per minute. But now think about it. How is that done? I mean, how do you get somebody's heartbeat into the length of a pendulum? I try to do myself, and it's just impossible. I can't do that. So I assume that you will have to have a certain situation in which people who are involved both have to have a musical ear. So, for example, somebody can listen to the beating of a heart, and then the other one, I will say, like, would you, like a walk or move the pendulum up and down when you come to a certain point, I will say, okay, this is a synchrony, stop there. And then you use this as a measurement of the movement, which then you can quantify and so on. So then you have how this organic world of one's heart can be converted into application of mathematical law. And then, of course, once you do that, you don't need a heart anymore, unless, like in the United States, the official declaration of one's death, who is on a death penalty, is the measurement of the last heartbeat. So to have a measurement of the heartbeat, you have to have a mechanical time that was developed out of the pendulum that was developed out of the listening heartbeat. It's coming back and stopping somebody's heart or measuring the end of somebody's heart. Okay, so once experiments are being done, and once we learn about Galilean physics, that raised some philosophical questions. And one, of course, one of the first to question the presupposition of Galilean science was Husserl, who said, like, well, Galileo is a great discoverer, but also he's the great concealer. And what he conceals are all these things that are not part of the formal knowledge, right? Is that which is not in the physics itself and yet cannot be reproduced, it cannot function without this non-formal knowledge that is, or what he calls a Lebenswelt. For Heidegger, Husserl's students, experiment was something even more radical, in the sense that experiment with instruments they don't tell us anything about nature. It's basically a construction of set of practices and instruments that interact with each other. And therefore, they're only telling us something about this arrangement rather than about nature. So here is what my task was here is to have a detail of this history of this discourse. I took one of the many descriptions that Galileo had about pendulum to show the relationship between mathematical and mechanical, where he says that if you take three pendula of a length that are in a ratio of 4, if you have a pendulum of the 4 units, the other one of 9 units, and the third one of the 16 units, and if you swing them at the same time, when the longest one makes 2 swings, this one will make 3 swings, this one will make 4 swings, they will actually swing together, and then they will go apart, and then again will come back, which we're supposed to demonstrate the mathematical intuition to be displayed by the motion of this pendulum. So let me just say here that one thing that working with the pendulum is that they are all set of technical issues that Galileo doesn't talk about. It is like physics books, you will find formulas and proof, but there's no really physics in it. In math books, everything that is in it is math. But in physics, you have only a part of it. What is not being given in those textbooks, you have to discover yourself. And so you have now different ways in which these things can be solved. So here is an educational pendulum, which you can order in a catalog. And this is a pendulum that was built by a student of mine who had a class in which they will have to build a pendulum and then demonstrate this same phenomenon here and write about not only the proof, but also the building of it. And what does it take to build a pendulum? How do you get? And of course, none of the pendulum are identical. My students brought like 30 different pendula. They have a different understanding what is the best way to demonstrate this example. So this is one which I find it pretty handy. But I don't want to bother you now with all of the intricacies about finding the proper length, how to do it, and so on and so forth. But what is interesting is that, as Heidegger says, he said, well, in nature we see things three-dimensionally, but in experiment, like here, you're creating a screen. So here you have all things are in one two-dimensional space. You basically have a screen in which everything happens. And therefore, this structure also defines from which angle you're going to look at it. Right? To see the phenomena, you cannot see it from anywhere you are. You have to be in certain position. And therefore, phenomena is interactively produced. You need more than one person to actually demonstrate that. And sometimes you need more than one hand to demonstrate it. So it's already very interactive, and therefore pendulum is not just what you see here, but it's this use and the setup around it. And so I'm going to demonstrate you here some aspect of it, and some of you will see better, some of you will see maybe just part of it. But of course, if you are sitting there, you will see the symmetry, and therefore it might be better way of seeing it than if you are sitting over there. So let us see if there is a synchrony, as Galileo said. So here I'm going to do first these two balls. One is, so this one is 3 times longer than this one, and this one will have to move 3 times, and this 4 times, and then they're going to swing together. Okay. Is that evident? Okay, so these two actually confirm his mathematical. So let's take these two. So this one was going to make 2 long ones, this one 3 ones, and they're going to move together. Now. Right, so there's a rhythm to it, depending on the length. So now, the task is to move, as Galileo said, like, oh, you take these 2 balls and just move them together. Well, how are you going to do that? You know, you have to have a hand of a gorilla to get all of this into a same plane, right?
Or Donald Trump.
Was that what?
Donald Trump's hand.
So it's a challenge. So let me just. So I will have to position myself like this, get these 2 and this one. But they have to be on the same line. Oops. I used to have a longer hand. I don't know what happened. Now, right? So now, Galileo says, well, if you do that, if you leave it like that, it's going to swing the rest of the day. BS. There's no such a thing, which means that now you can now see how actually they move out of the 2-dimensional space and start spinning around, right? Well, that's because that's the Galileo, that is the Foucault's pendulum, right? Is like basically the movement of the planet creates this circular motion, which creates, for Galileo's demonstration, a problem, right? Because you're not only dealing with one force, but also the gravity force that is in a course of movement. Now, of course, all of this depends on the material, the size, and all of these things that are not part of the formal knowledge, but is there, meaning that even though we don't have original Galileo's materials, it is arguable that he must have struggled with the more or less same practical problems as we do. Right? So there is a way in which intersubjectivity can be reconstituted on the ground of the problems at hand, such as, tying a knot or finding the best material and so on and so forth. So, okay, I'll stop here. Those who didn't fall asleep might have a question.
Or come up and try the pendulum yourself. But to sort of help the questions along, since we're on the topic of radical ethnomethodology, and this is something that I don't think was done by Garfinkel before studies in ethnomethodology. And so it's novel, in a sense, as a demonstrative device. He also credited it with a strength, if you could call it that, which he contrasted to analytical ethnography. And he sort of valorized the practical competence that's embedded in the performance of this, as opposed to, of course, a description can be made without mastering the practical competence and made to an audience who has nothing more than appreciation of it. And so he saw this to be very promising, but it's also a very limited sort of device, particularly when you think of it coming out of sociology. A sociologist, maybe not even a conventional sociologist, might be inclined at. So where's the sociology?
Well, if I may jump here, I think that the only real, what is ethnomethodological contribution to social sciences is that the only reality is reality of practice. There's only practice, and everything else is superstructure added depending on your style of representation. But in reality, we're always doing things. So when you say society, you mean people doing things, whatever they're doing, right? So in that sense, we're doing something here, and that's all that is to it. And when you say, where is society? Well, you just discover your own problem because you want to see something that is not there. If it's not there, it is not there. Why do you have to force bringing something into it if you don't see it?
Okay, then the question is, what do we see? But Bob has a question.
Well, sure, that I would suggest actually that the sociology is that it demonstrates the whole piece, the whole of Dušan's presentation. It demonstrates the recoverability of multiple realities, and that what you get in Galileo's dissertation is the discovery of a mathematical reality, and what you get in your reattending to his dissertation is the discovery of a practical reality, and the demonstrating of them both in terms of the methods by which they are produced. And so I find in that the sociology, rather than the sociology of the pendulum per se, it's actually the sociological. I don't like the word demonstration. Instantiation might be better. Instantiation of the recoverability of multiple realities.
Yeah, I use the word demonstration because the historians are reluctant to credit this with being an experiment. And there was a long debate, and I guess it's still continuing, about whether Galileo needed to do this kind of physical manipulation to come up with his laws of free fall. And I think Stillman Drake is the one who argued and tried to demonstrate that musical ability as well as mathematical ability was involved, and that the performance of the inclined plane was necessary.
Does it matter whether he did or he didn't?
What?
Does it matter whether he did or
Yeah,
he didn't?
well, for us here, probably not so much. But if as you formulated, the issue is the instantiation of a Galilean era physical law in an apparatus, this is a way to do it. A way to do it. Although there's a big argument with Eric Livingston about the salience of mathematics to this or the embodied practice
Yeah, for Eric, my disagreement with Eric is that he thinks that the way you talk about math is the way you can talk about physics. That the protocols for doing experiment and the proof are two sides of the same coin. And I was arguing that actually in physics you have the missing part of it, which is all of these contingencies that you have to deal with bringing your body. So if you look, for example, his account of the pendulum experiment, there's no account of his own body. His body is a ghost. He is not part of it, and the only thing that he shows are the procedures. In other words, once you have a law, you know how to break down your procedures logically to arrive to the proof, right? But outside of this, there are all kinds of unexpected surprises that your body in relation to instruments have to count for. That physics simply cannot identify. That's etc. problem. There's so many things that I don't know, but it's always the physics cannot function without some non-analytical, non-formal knowledge being part of it. I remember when I was as a graduate student doing some observation in Lincoln lab in MIT, and the lab is just a factory. It's a totally mechanized process. They were observing a sample of gas behavior of molecules of the particular gas on the close to absolute zero temperature. And I was saying to the physicist, like, well, you know, you're basically just an engineer, you're just running a machine. And he says, yeah, but all experiment depends on a sample. I said, okay, why is the problem? Because only few people can produce good sample. And you cannot teach people. It's like a good cook. To mix in a way that actually all experiment depends on is something the physicists don't have as a part of their training. You have to have that what Garfinkel called golden fingers, right?
Yeah, but isn't that just tacit knowledge?
Was that?
Isn't that just another way of talking about tacit knowledge?
Yeah, yeah. But that's not part of the formal knowledge. All right? So in math, everything that you know is in display. In physics, there's a lot of things that are not explained, but are contingent and a part of the work.
So do these kind of demonstrations add anything more to what Garfinkel, yourself, and Livingston said in the pulsar paper? Because he points to the very phenomenon, the live work of doing science, right?
Yeah. He always treated the pulsar paper as very inadequate because we never built the apparatus. We actually explored the possibility of building the apparatus so that we could reproduce the phenomenon in this sort of way, you know, get the pulse. And I never knew, you know, I never had a clear idea of what we would have.
But in a sense, it's like in computer science, you get this lovely phrase like implementation details, right?
Yeah.
You know, it's sort of like an implementation detail. It's just more detail. You know?
Well,
the analytic point, the grand analytic point.
Well, I guess that's the issue. I mean, okay, we can talk about demonstrating the mathematical law of free fall that Galileo formulated and had to correct because it was a bit off. But let's say we're in this, not demonstrating an ethno-methodological law, but using it as a pedagogy for addressing something like asymmetric alternates. So to go back to what Dušan was saying, we could say, using that language, that you can formulate the law that it in advance or after the demonstration or the instantiation, if you like, but that in the course of doing this, like when I do this, Dušan is quite adept at this. You discover all sorts of stuff that doesn't work so well when you have not mastered this. And when you try to do this in an environment, look at that, a new effect, just getting the apparatus is a pain. have them in Paris, right? We had to go to a machine shop to get something that would be approximately 90-degree angle that we could mount on a table. And it took, you know, it wasn't immensely difficult, but it took a day or so to round up this stuff. And, you know, Dušan has been working on this for quite a long time, right? So he's adept at it. And the point of turning this into a discovery process of the sort that little kids discover in their science classes is that you find that there's more to it than the formulation. And then the methodological formulations that you get out of the pulsar paper, Garfinkel's program, those sorts of things, can be not necessarily re-specified, but understood in a different way when you engage with material, which is why there's this insistence that you don't just read and comprehend, but engage in it and get a sense. Now, whether that matters or not, whether it's just a matter of a personal sense of having understood something in a different sort of way.
It's a study of work, right?
What?
It's a study of work. The work to make the technology work.
Yeah.
Yeah.
But if you formulate it that way, but then.
Well, that's what. Yeah. Well, that's a phrase we use quite a lot in
Yeah.
design, right? Because it maps to computational systems. The work to make technology work.
So, no, say that again?
The work to make technology work.
The work that, yeah, which is a lot of work.
Yeah.
Yeah, and we can say it's a lot of work, but that doesn't do that. Another thing that comes out of this sort of program, and it doesn't necessarily have to do with pendulum, is the formulation that comes out of Garfinkel that each science is a distinctive science of practical action. Right? So that earlier in the earlier session, we were wondering, you know, maybe sociology has nothing to do with this stuff. There's two ways to think of that. One is the discipline of sociology has very little to say about this kind of phenomenon and really doesn't see it to be missing from the pedagogy of sociology. You need to be talking about this kind of thing. But it's also another way of understanding it is that each practice, developed or organized practice, has its own sociology, right? Its own praxeology, its own pedagogy that isn't necessarily bracketed away from all others. There are bleedings between language games, and you know, borrowings of concepts, apparatus, and that kind of thing. But the whole idea of hybrid studies is the masteries are engaged in a practice. Now you could question this, and I would question this, that okay, if Dušan is showing us a practice, what's the practice? Right? Is it scientific practice? Is it a historical practice? Is it we now have an ethnomethodological apparatus that this will be every time ethnomethodology is taught, you better get yourself a pendulum. That will be part of it. Yeah.
Actually, Mike, it's neither. What it is ordinary practical capacity.
Much of this, yeah.
Yeah, well,
Yeah.
much of what Dušan was doing,
Yes.
you could do with a couple of pieces of card. You could do lots of different ways, and
Yeah.
that is to hold the pendulums back.
Yeah. One of the things.
But none of that's got anything to do with physics. None of that's got anything to do with this demonstration. It's got to do with practicality in the world. And what you're demonstrating is that the physics, for whatever purposes, this is physics. Because this isn't discovering physics, this is pedagogic physics, if it's anything. And all of that stands on the practical capacities of operating in the world. And you're just demonstrating some of the ways in which it stands. Okay? It also stands in lots of other practical capacities, also touched on, like you've got to be able to put things together. And you've also got to be able to stand up and explain what you're doing.
Yeah.
I'm not trying to denigrate it. I'm just.
Yeah, I understand.
What I'm trying to do is deflate it, because we do tend to overhype this stuff. And what it's a very good demonstration of what is, I think, an important but not over-important point, that it stands on common sense of practical capacities. And we all, more or less extent, have these things, and that's what scientists have, and they learn how to do it. They know how to operate spoons. They can feed themselves, so they can work some machines. And they learn how to do that. And that's part of becoming a scientist, learning how to apply these skills there. Why
Okay.
make a magic out of it?
No, who's making magic of it? But this kind of apparatus allows you to see allows you to cultivate the skill, which isn't. It's not common sense, really. It's you start with, a body of some sort, with an apparatus, and of course, any apparatus will do within a certain set of specifications. A lot of different ways of releasing those bobs can be done. Sophisticated mechanical ways, unsophisticated ways with hands or pieces of cardboard and whatnot. There's questions about how you count, how you see the synchrony, all of these things. And they're part of this practice of whatever this practice is, right? However we formulate it. And they're cultivated with it, and you see extensions of it as you can do it with a different apparatus altogether. And so it's more than an application of common sense because common sense needs to catch up to whatever, common skills, let's say, don't get you the synchronicity immediately. It has to be developed, which is nothing, huge, newsworthy.
Don't we know all that?
What?
Don't we know?
Yeah, I was going to say, we we know this.
So, why you can't well, what new
What news is
things
there? Yes.
are you bringing to the table then?
This? No. The claim about it, I'm questioning that too. The claim about the radical character of this is that it's not a formulation. It's a production that is trying to break out of the kind of textual formulation and understanding to a space where you demonstrate how to do things, how things are done within a particular game or a particular practice. That's the claim. I mean, that's what you get in Livingston's book. That's what you get in Garfinkel's chapter on Galileo. So it's nothing new.
Well,
We do these sorts of things all the time. The question is, what happens when it becomes reduced to literary?
Okay, may I just add to this? For me, the focus of my work is discovery of the thing. That is, say, my relation to the instrument, whether this is Galileo or not, in a way in which instrument or my relation to the instrument tells something.
Yeah, but
Yeah.
when Wes and I were talking about the paper that we're going to present tomorrow, one of the things we did was try and list out important pieces of work, right? And so we took the Pulsar paper, and I asked Wes the question, well, what's the bloody brilliance about that thing? And Wes's answer was just what you've said, but he got it from the paper, and it was one of the things that they demonstrated in the Pulsar paper was that science is more than just literary practice, and that's just what you've just said. So if that's recoverable from the paper,
It's not, but that's the whole point. But well, he can say whatever he wants to say, but it's not the same thing. I mean, like, it's to say, like, if I can teach you swimming in a classroom, and you pass the test with 10, it doesn't mean that you know how to swim.
no, I'm not saying that.
No, but it's the well, let me finish now.
Okay.
Is that the work with the instrument is in working with the instrument, period. Whatever you have in a paper about that without actually having this as a demonstrable and reproducible, you're not talking about the same thing.
No, but I asked the question what was new. Mark gave the answer that what was new was that it's more than just recoverable from the literature. It's that science is more than its literary inscription. That you have to find that through the embodiment. And what I'm trying to make the point is, last week or a couple of weeks ago, whenever it was, Wes was able to tell me that without having to go through that process. That what the excellence of the Pulsar paper was, that what it demonstrated was, for the first time maybe, that
science is more than, and not just, literary practice.
Of course, he said that before we wrote the Pulsar paper, so.
That's the promise.
Yeah.
That's the promise.
I fear it. I mean, if you follow Dušan's argument out, I mean, he really should be a physicist, and so should we, because what we're talking about is real physics that real physicists do, and this is just a proxy for that in many ways. So really, we don't have to be physicists to say anything.
Yeah.
So that can't be solved. One of the things that worries me, I mean, in the economic stuff generally, is this missing from the formal stuff. It's not missing from the physics. It doesn't matter to the physicists how the hell you get the balls moving and aligned. As long as you get them moving and aligned, they're happy. They don't care. You can do it by whatever means. And you may have to pass on the skill to people because, it's not. But it doesn't matter to the physics. A lot of how you do this stuff, it's not missing because you don't get it from the textbooks. You get it from being an MA student. I've got a student writing up on stuff, doing stuff in the lab, and they leave you to yourself. You're going to wander around the lab. I need a bucket. Where the hell do I find a bucket? In this lab, an astrophysics lab, where am I going to get a bucket? But so you have to teach yourself this stuff. And of course, it's a long career, and you've got to learn all that theory. It's not like, here's the theory, learn that in 10 minutes, now get that. No, you've got to learn all. You need the time to learn the theory before what you're learning to do practically can be done. So there's a sense in which, the version of physics as formal knowledge that's missing, it isn't. It's incorporated in the institutional practice of physics, through and through. And in a sense, all ethnos are ever going to do is a little token of what these people can do.
No, I agree with you. It's just that it never makes into a published paper. But there are moments in which actually successful demonstration is relevant. Let's say if you have first time of experiment and you're showing it has to work. Now, in the case of Galileo, most of Galileo's experiment, so-called experiment, were done in a Medici's court to entertain nobility, not to the scientific community because there wasn't one there. And so you have to make it work because they have to say, wow, right? So that there was that's why this successful synchrony musical dimension was more important than whatever it proves, right? And was done under the auspices or protection by Medici's, which means that if he went to the Rome and did simple thing like that, it won't be that easy as it is easy for us now because, for example, Jesuits didn't want to look at it. They thought this is demonic, I should look elsewhere, right? So yes and no, but back to my issue here is, as I said, in the studies, Garfinkel begins with the distinction between Kantian the definition of object and a social. Well, the same thing applies to the things in themselves, because things in themselves are really nothing other than tools in our practices, right? So the pendulum is in its use, just like words. Meaning of the word is in use, therefore pendulum is not in standing, it's in using it. So what does that entail? How do you make think in etymological sense? Well, one way is...
Yeah, but what in the way I'm arguing, I find this an ease with a lot of this stuff, formal representations and actual practice, the articulation of it, because I think you often trust the teacher a misleading lesson, and you say this stuff is embedded in the practices. That's what I'm pointing to. The practices that are actually involved in this are like, nobody really cares how we get these bloody balls swinging, as long as they're swinging, and then we can see the thing. It's not missing, it's not absent, it's not needs recovering, except, of course, the lesson for sociology is, for actual persons, all of these things arise as very specific configurations. You can't have a general account of the organization of action that sweeps across this stuff because you can't appreciate how these things get produced. I mean, that seems to me the lesson. It's about how social order gets produced in actual cases, because there's no generic production of social order for people to survey and generalize. There are ways of producing social order, and they're multivariate. And so but the thing, and I always say the great thing about echo, it doesn't matter what you study, you can show the production of social order with it. But then there is the question of like, how many things do you want to study to show people that the production of social order is local, refined, the rest. And these seem to me kind of questions that get left aside mostly. So I think there's still a good issue about what sociologists could take from this, because they could take things from it. And also, as I said, with the popularity, like, is it tacit, is it explicit? Yeah. You know, I mean, what do you have to say to say something? The fact that you don't put it in these words, I mean, so many words, as Howard put it, it doesn't mean you didn't say it, and it wasn't there. Yeah, so you know, the way physicists and stuff speak of these things just presupposes a lot of stuff that any physicist will understand. It's absolutely so. Harry Collins' stuff, you know, it turned out they found out the length of the cable was mattered, which they didn't know, because when they first put the cable in, it all went fine. But it's not like it was fantastically found that in science, you know, the capacity of equipment to produce an experimental result depends on the length of the cable. Yes, it does, or something else, or something in a catalogue is vast and varied. And, yeah, so it's sociologists that are the problem, not the physicist representation of these things, because that's part of their practice.
Isn't the danger, I mean, well, I would suggest we're slipping into it, is trying to find out what the experiment is, trying to define the experiment, and the danger that you could hear Dušan was saying, well, Galileo told you this, but he couldn't define the experiment, because he's the one out of the stuff he didn't talk about. And West just come back and said, well, actually, there's lots of stuff there to talk about. And the danger is that we think there is the experiment, and that somehow or other we're missing the description of it. And if we added lots of bits to it, your description of its embodiment, Galileo's descriptions of its mathematics, Wesley's background descriptions of all the things they had to do, including finding pockets and everything else, we would have the experiment. No, we wouldn't. The experiment is constituted on occasions, for purposes, it's written up in journals as this kind of thing, and it's spoken to as among friends as that kind of thing. The experiment is a budget of troubles of things I've got to get done before next Monday. And for your purposes, the experiment is a collection of embodied practical actions that enable the experiment to happen. Those are all perfectly good constitutions of the experiment. We don't have to choose amongst them, and we certainly don't have to find a way of stitching them all together. And I think the danger is that we're trying to do that.
I'm interested in the way that you link this to Sudnow's stuff in Ways of the Hand, because I always found that a very odd book, because he starts with, well, here's playing piano, which I can't do, here's touch typing, which I can do, and I'm going to tell you how it is that you can do this. And there seems to be a hole in the middle of the book, which is where there's a description of how somebody who can't do this is able to do it without just saying, look, now they can do it. And you sort of reproduce that by when you were operating the pendulum like now, yours was rubbish, so it's going all over the place. But I don't think you could write a description of what it is that you do that's different to what might be. And that's the promise that Sudnow opened up. In some ways, doing this demonstration seems to be something where it's saying, well, there are things that you can do, like driving, touch typing, playing a keyboard, that can't be described in words. You can only show them, which would go into is quite Constantinian territory. There are some things that you have to just be shown, and in some respects, you can see that relating back more clearly to an etymological tradition than questions about science and the status of a scientific proof in comparison to the other works around it.
Well, you're right about this, and in my book I talk about, I'm asking a question, why is it when somebody produces harmony on a guitar or harp, people say, oh, what a wonderful fingers. But when we produce the same harmony with the pendulum, we see the law and not the work of finger, right? It's just like there's a black hole in which the actual work disappears, right, into the law. In that sense, something is missing, right? It is almost like a magical thing, transform your perception. You're seeing things in a way, as Heidegger would say, to confirm what is already there before is to be seen. Instead of seeing this as, wow, he has fingers that produce this synchrony, as if producing a synchrony of a sound.
I was looking at the point of the post paper, one of the points of the post paper was that alongside formal methods accounts and members' methodologies for bringing off those accounts, or those accountable activities, the discovery of the postdoc. One assumes that you will be able to provide us, or somebody studying you, with a kind of methodological account of how you assemble that item and make those statements. There's no news there.
Well, I think that
it's just a
Garfinkel,
demonstration of the same point.
I think Garfinkel entertained the possibility that the practices of making this thing work, and it does. One marvelous thing about the pendulum, when I used it in L'École des Mines almost 20 years ago, I think Bruno Latour said, this is the first time that we've had something besides talk go on in this seminar room. He also pointed out something that was kind of interesting, is that if you read Harry Collins, you would figure that you'd never be able to get any of this stuff to ever work, right? Because it's so contingent, so dependent on skills that are very difficult to cultivate. Whereas with this thing, you can get it to work, depending on what you consider work, working. But you can get people to see the law-like relationship.
Well, I'm not sure you demonstrate any law at all to me, to be honest.
Yeah, but I mean, you can resist the lesson, but
if you talk about, if the switch, if one of the points you're making is about, it ain't just about language. There are many modalities to interaction, and we need to consider those.
Right. Yes, but where Garfinkel wanted to go was with language in a way to not just settle for the ineffability of the skills that Dušan has mastered and I haven't, but to describe those in greater detail, much in the way that conversation analysis after the advent of tape recording phone calls was able to go into great detail about the procedures used in conversation that arguably are recognizable by people who have mastered those skills, but which aren't articulated, don't need to be articulated in order to do them. And so I think he envisioned something about how you would never, of course, exhaust the phenomenon of the embodied practice of this, but that you would have a device for articulating them, making them recognizable, and that you would, there's a line out of Foucault that I like, which is to push the foamy line of language further, right, where language meets the beach, the analogy, that you can press things a little bit further, language into this practice that often gets consigned to ineffability. You can engage with that, you can articulate it. And I think CA was probably, well, it had to be, was a model at that time of what can be done with an instrumentation and a practice of articulating what articulation is, among other things. And whatever you think of CA, it did try to push language into descriptions of practices that otherwise would be considered tacit, not necessarily ineffable, but inarticulate because they don't need to be articulated.
It seems to me that one thing about ethnomethodology is an element, often in text, and I don't think she necessarily intended the text of showing rather than telling. It happens in all sorts of ways, and exactly right. In conversation analysis, you are showing how somebody did hear it, not what the sentence might mean, could have meant, could be variously read, but was taken up and understood in a particular context. Just struggled through Wittgenstein's remarks in the philosophy of psychology. He keeps coming back to Gestalt pictures. Everything's changed, nothing's changed, everything's changed, nothing's changed. And he goes over this endlessly, going back to the same pictures. And that's in a text, but seeing the aspect important things, but suddenly things have shifted, and a lot of texts are very good at showing that shift. But I was thinking about a paper that Wes and Evander were involved in, psychotherapy structured immediacy, because you can also see things in ways which you could never figure how it might be used in a particular way. And the pedagogy is you get guided into seeing how practitioners in the scene did use it in that way. So in this case, it's to take traumatic experiences amongst very young children using a piece of plasticine, Play-Doh or whatever. And in that paper, you do get a demonstration. You do come to see how it might be that this piece of plasticine takes on these features within a psychotherapeutic context. Now, it's in text, but that seems to me a demonstration as well, or a showing, if you like, and one which I think is incredibly valuable. So this stuff seems to me to be part of a wider range which ethnomethodologists go about exhibiting, demonstrating, showing in a whole variety of ways, which does make it extremely distinctive compared to a lot of social science, which is usually didactic and telling in character.
Well, it points to that Gothic will talk about labels on pairs in the paperwork, you know, and it's the idea that text is instructive text that, demonstrating phenomena, making it recognisable.
But the text can also be really good in that respect.
Yeah, absolutely, yeah.
What did he mean by docile text? He had that expression, I never quite understood. Docile text.
It's what the Mandarins manipulate.
I give it a simple gloss, which is the best I can do right now. I believe it meant that with a text, an interpreter can make it out, not any which way, but so many different which ways that any given interpretation has no particular claim to authority over any other one.
I find something actually somewhat disconcerting about this demonstration. I get almost confused about what is a demonstration. If I look at it mathematically, then I find it not surprising at all.
Mm-hmm.
I mean, I could probably still calculate why actually
Well, if you
goes
have a
together, but hold on. But then there is another thing which actually, but it also demonstrated something else to me, that actually I'm not looking at it simply mathematically, because as I looked at it, there seemed to be an acceleration, certainly this one, when actually they meet in a particular way, it seems to suddenly speed up. So actually what it was demonstrating to me was two things. One is that I could probably, that actually I'm not looking at it right, or certainly not looking at it right in a mathematical way. So I'm actually now puzzled about what is it demonstrating. And if I used it as a demonstration, I actually found this for myself, that actually there's a bit which is actually odd, visually, phenomenally. Then I would have to actually redo it as a demonstration of the mathematics underlying the pendulum. So, I mean, did anybody else see that actually there's a little
Right,
speeding up?
so the whole demonstration is very noisy, but because you have in advance given mathematical picture, so it is like epistemic prosthetics to a
Yeah, but is that a noise or is that not a noise?
Is it what?
Is that a noise that's speeding up? Is that to do with your manipulating it in a particular way? It could be, it could be made better, like,
could be also string, could be angle. There's so many things that. But for Galileo, is that if you see in a general sense, it's enough, right? In other words, what he called proof is not something that will be accepted today for our standards.
But it can't be speeding up mathematically because all those
so what you're saying,
are independent.
you could use this to demonstrate illusion.
Yeah, that's what I'm talking about. That there's an so it's demonstrating both an illusion.
No, I
and
noticed
the
something too where it
mathematical.
almost seemed, when they synchronized, just watching two at once, it almost seems like they changed their motion.
Yeah, that's
Now
what I'm talking
we're
about.
doing
This is
physics,
speeding
right?
up.
What?
Now we're doing physics.
Yeah.
Yeah?
No, we're talking
No, really?
we're doing psychology
No,
because
this
it's
is-
about illusions. But anyway, Philippe has been very polite in trying to ask a question for the last half hour. So this will be the last
I mean,
question.
it's basically if you're interested in how an experimental physics demonstration works, be be it a Galileo or a classical one or in other fields, any kind of experiment, might be worthwhile to try to have a go yourself and to see what that might change from filming people at work and how you might develop your understanding or change your understanding of how they produce whatever they're doing as this or that kind of move in the kind of physics they're doing at that part of the day and so forth. I don't see why one shouldn't do that. So if you want to do a study of say scientific work, probably you have to go through the in. Yeah? If you want to specify the say the embodied methods of the recognizable production of say whatever you've demonstrated to us here and so forth, so that the thing becomes formulable in the relevant time. So I don't see much of a debate here because, well, anyway, if an ethnomethodological study is of interest, in terms of. And then the other thing I wanted to say was, well, in the thing, we are at the risk of thinking about the experiment, but then again, well, who is we and what is the experiment? So, I mean, it made me think of this piece by Egon Bittner that is quoted from time to time also by Wells on objectivity in the social sciences and so forth, where the ethnographer is kind of projecting his or her relativism or skepticism on whatever members might be doing in the field, because, well, at least from the sense I got of what physicists, I mean, to them it mattered pretty damn well how you do those things to get them exactly. I mean, there's basic requirements to be met in experiments such that they can count as such, but that, I mean, this is just basic kind of reminders, and it mattered very much to them. It doesn't mean that it is missing from the papers, but to some of them it misses actually. Well, and so forth. So this is something that is up for grabs also to the participants themselves. So for certain things, and if one wants to describe how this demonstration is produced as an ethnomethodological achievement, presumably it would be quite impossible to do. Well, you can do it, but then there's, as Mike suggested, I mean, you can describe much more than these tacit, I mean, what is considered tacit skills, because they're somehow implemented. No, that's presumably what happened.
So,
Mike, can I just
yeah.
ask you to finish, but I'll finish on a positive note, because I can see a use for this, and I can see a use for the way in which Dušan demonstrated it, and we haven't really talked about it. And it's this, that all of us who taught as a methodology start from a point at which what we're talking about gets a completely blank stare from people, because we're talking about things they've never thought about. And it seems to me that the real practical use of this for us is not in actually trying to replicate Dušan's interest in the embodied character of physics explanations, but rather in a demonstration of what the missing whatness is in the accounts that people will have to provide if they do ethnomethodology. In other words, it is pointing to the phenomenon of the missing sets of actions that sit behind what is out there as the obviously recognizable, the experiment that gets done, the readings off the screens, the practical coding that people do. We all go in and see. What are you looking for when you do this? When I send you out to do an experiment or to do a study, what are you looking for? Well, you're looking for this kind of thing. It's the equivalent of the lab work for practices for neophyte physicists and the lab work for neophyte engineers, where you can see and learn how to do the practical work yourself. Because Dušan's doing it for you, and the task is describe what I just did. And I think that's a very practical use. But I think the other thing is also demonstrated is you can take something very simple and operate and fill up an hour generating an argument over it.
Yeah.
And that's methodology work.
Okay.
And the other one is that we don't use videotapes, we don't have a transcript.
Yeah. Oh, how shocking.
What that?
I said, how shocking.
Yeah.
Yeah, you'd be drummed out of the discipline.
Well, as I
yeah.
said to Jeff
Okay.
yesterday, I said, do you remember those times when it had been, when can we have a data session?
Yeah. Well, we had a data session here. We don't know if the data up, but that's right. So.